Hi, I'm Prof. Johnny. Welcome to Goodwill Training and Assessment Center Incorporated. May kasabihan tayo na sa Diyos ang awa, na sa tao ang gawa. So ano pa hinihintay natin? Tara na at gawa na tayo! This is a continuation of taper turning. This time, I'm going to cut a taper using the taper attachment method. There are two types of taper attachments, namely the plain taper attachment and the telescopic taper attachment. The telescopic taper attachment is more convenient to use than the plain taper attachment. This is the telescopic taper attachment of the lathe, which consists of a guide bar, connecting slide, the graduated plate, the adjusting screw, the sliding block, and the two lock screws. I will make a workpiece with the same taper angle with what I've done in the compound rest method, which is a morse taper number 4, which is a taper per foot of 0.623 of an inch, a large diameter of 1.231 of an inch, a small diameter of 1.02 of an inch, a taper length of 4 1/16 inches, and an included angle of 3 degrees approximately. The procedure to cut a taper using the taper attachment method is as follows. First step, clean and oil the guide bar. Yeah. Next step, loosen the lock screws and offset the end of the guide bar. The required amount or 4-inch attachment, set the bar to the required taper in degrees or taper per foot. So here are the two lock screws of the guide bar, which need to be loosened so I can set the guide bar into half the included angle of morse taper number 4, which is 1.5 degrees. Here is the indexing line inscribed on the guide bar. And this is the graduated plate in which the zero mark is at the middle with a maximum angle of 10 degrees on both sides. I will now set the guide bar into 1.5 degrees towards the left side of the graduated plate by rotating this adjusting screw clockwise so that the guide bar will move into the left side. Okay, 1 degree plus 0.5. Okay, so 1 degree plus 0.5 degree. Okay, take note, if the small diameter of the taper is on the right side end, the guide bar should be set on the left side of the graduated plate. And if the small diameter of the taper is on the left side end, then the guide bar should be set on the right side end of the graduated plate. Then next step, tighten the lock screws. So I will now tighten the two lock screws. Okay, next step, set up the cutting tool on the center. Already set up and positioned 90 degrees to the workpiece, and tighten the tool post. And next, set the workpiece in the lathe and mark the length of taper. Okay, here is the length of the taper already marked. Okay, take note. If a plain taper attachment is being used, remove the binding screw in the cross slide and use it to connect the sliding block and the connecting slide. The compound rest must be set at right angle to the lathe bed. Then, move the carriage until the center of the attachment is opposite the length to be tapered. Okay, I will now move. Here is the center of the attachment. I will bring it opposite the length to be tapered or in line with the right side end of the workpiece. Okay, ito, in line na siya. This is to ensure sufficient length of travel of the sliding block to complete the taper. Okay? Next step, lock the anchor bracket to the lathe bed. So this is the anchor bracket of the attachment. I will now lock it to the lathe bed. Okay. Next step, take a cut 1/16 of an inch or 1.5 millimeter long. Stop the lathe and check the end of taper for size. Okay, just like what we have done in other turning operations, we need first to set the tool bit with a zero reference surface by taking a very light ring cut around the periphery of the workpiece, followed by a light trial cut to produce the true diameter. Okay, I will now switch on the machine. I will measure it. At 32 mm. I'm using metric system of measurement because the graduated color of the cross slide of the machine is in millimeters. Next, set the depth of the roughing cut to 0.05 to 0.06 of an inch or 1.27 to 1.52 millimeter oversize and machine the taper. Okay, I will set 2.5 millimeters depth of cut for roughing cut and I will leave 0.5 millimeter depth of cut for the finishing cut. Then take note, start the feed about 1/2 inch or 13 millimeter before the start of the cut to remove any play in the taper attachment. Pansinin nyo, mula sa dulo ng workpiece, there is distance between the tool bit, at least 1/2 or 13 millimeters to remove any play in the taper attachment. Okay, I will now employ the roughing cut. Okay, this time I can use automatic feed. Unlike in the compound rest method, which is done manually. And take a look at both the workpiece and the taper attachment. The tool bit travels along a line which is parallel with the guide bar of the taper attachment. Thus, the taper angle produced into the workpiece is the same with the angle set on the taper attachment. Okay, the length of the taper already obtained. So I will bring back the carriage to the right side end of the workpiece. And there should be a distance at least 1/2 inch between the end of the workpiece and the tool bit. Then the last cut, finish turn and feed the taper to a gauge. So let's have the finishing cut. So I will feed 0.5 millimeter. Then of course, a lower feed rate and higher RPM. Then cut. Again, look at the workpiece and taper attachment. The tool bit travels along a line parallel with the guide bar of taper attachment, which is set to 1.5 degrees. Okay, the finishing cut is done. How to check whether the required measurements of the taper are obtained? You may do the same with what we have done in the compound rest method. You may check the link on the description box. Now let's have a Q&A portion. Prof. Johnny, pakiklaro nga yung step number 6. Bakit kailangan yung gitna ng taper attachment ay dapat opposite the length to be tapered or nasa right side end ng workpiece? Okay? Itapat ang gitna ng taper attachment sa right side end ng workpiece. Just like what I've done. Bakit? Subukan nating ilayo ang gitna ng taper attachment papunta sa kabilang side ng workpiece. Okay, luwagan ko muna ang anchor bracket. Let's move the carriage to the opposite end of the workpiece. Ito yung gitna ng taper attachment. Dadalhin natin dito sa left side end ng workpiece. Okay. Then, ilak ko uli ang anchor bracket. Yan. Tingnan nyo. Dadaling ko ngayon ang tool bit dito sa starting point natin sa right side end ng workpiece. Yan. Andito pala yung tool bit natin. Wala pa tayo sa starting point. Pero bumangga na yung sliding block dito sa lock screw. Kaya, hindi ko na ma-perform ang taper turning. Dahil hindi ko madala yung tool bit natin sa right side end ng workpiece. Diba? Yan o. Yan, bumangga na dito yung sliding block dito sa lock screw. Hindi ko naman pwede ilipat ang tool holder natin dito sa right side ng tool post dahil kapag nag-cut na tayo at nandito na tayo sa left side end, tatama naman ang left side ng tool post dito sa chuck ng machine. Another Prof. Johnny, ano ang mga advantages ng taper attachment method in taper turning? Turning a taper using the taper attachment method provides many advantages in producing both the internal and external tapers. The most important are the following. Additional knowledge. The Morse taper was invented in 1864 by Stephen A. Morse, an enterprising mechanic who developed it to accurately join two machine components. And lastly, please wait for the last taper turning method. I'll be performing the tail stack method.